Oh yes, welcome to DC Economics. So coherently, we are going to talk about on how we can calculate the average rate of change. So I beg you to go with me attentionally so as you can understand the concept. So how to find the average rate of change? For example, let's consider the function that is y is equal to 2x. And suppose a we are required to determine the average rate of change of the function in a closed interval of 1 and 4 of the argument. And b, determine whether the function is concave or convex using geometrical test and specific value of q which is equal to 0.3. And c, we have to do the concavity or convex test using the derivative condition. So the part C, we're required to do the concavity or convex test using derivative condition. Let's go to solution A. The first part we're required to find the average rate of change. The average rate of change of the interval A and B is given by the function of B minus function of A, minus the function of A divided by the B minus A. Remember, the interval we are provided is 1 and 4. And also the function we are provided is y is equal to 2x. So the average rate of change will be equal to function of b minus function of a divided by b minus a. Remember, the interval is a is 1 and b is 4. So the average rate of change will be the function of, that is 2 times 4, minus the function of a, that is 2 minus 1, divided by b minus a. B is 4 and a is 1. So when you divide it, the average rate of change is equal to 6 divided by 3. So the average rate of change will be equal to 2. Remember, as I told you, we times 2 times 4 because the function we are provided is y minus 2. Y is equal to 2 times x. So we times x, the function is 2x. So we times 2 times the function of b, that is b is 4, and minus the function of a, that a is 1. So the result will be the average rate of change will be equal to 2. B, we have to now to show the concavity. We determine the function whether it's concave or convex using geometrical test. So for the geometrical test, remember, for any geometrical test, for concavity or concavity, we look at the curve of the function and observe whether it is bending upward or downward. So the function that is we are provided, that is y is equal to 2x, is a linear function. So its graph, it is a straight line. So since the slope is positive, now the graph is bending upward, indicating the convex function. Now our graph up here, the convex function goes upward, but also we have the concave function and convex function as observed. So convex functions occurs when the second order derivative of function is greater than 0, but also the concave occurs when the derivative test of a function is less than 0. So by using a specific value of q which is equal to 0.3, if we plug in the values of x 0.3 into the function of y is equal to 2x, we'll obtain that is 2 times 0.3, which is will give us a 0.6. So as you can observe, since the answer is 0.6, this means that the point lies on the curve of the function, since the curve is bending upward. So it supports now the conclusion that the function is convex. So it supports the conclusion the function is convex, since now we obtain 0.6. The positive answer. This means that if we obtain the value that is greater than 0, prove of the convex function. Now let's go to part C. We need now to use the concavity or convex test using the second order derivative test. We need to check out through the second order derivative test of the function. So if we apply the concavity or convex using the derivative test, the second derivative test can be able to determine concavity or convex by analyzing the significance of the second derivative. So y is equal to 2x, we apply the first order derivative, will give you 2. But the second order derivative will give you 0. Since now the convex is proved where the second order derivative of dy squared over dx squared is greater than 0, this means that the function is convex. And if the second order derivative of dy squared over dx squared is less than 0, that's prove the concavity. So in this case now, if the second order derivative of the function is provided from the 2x, this means that the second order derivative will be equal to 0. So 0 actually does not tell us whether it's concave or convex. So we need to go further and apply the geometrical test to see we need to have more interpretations by applying other geometrical interpretations in the point of evaluation. So in such, we can conclude now our summary. The average rate of change is 2. The second derivative test lies in geometrical interpretations, and B now geometrical test is convex. So that's marked the end. Welcome to DC Economics. Bye bye.